Hi, this is Nick Schrammick. I'm here again with my partner, Howard Chao, and this is our podcast, What's Next In? And today, Howard is speaking to the founder of Skyroads. Skyroads is a German-based startup that has a goal of making flying accessible for everyone. Their automated airspace management system will allow unmanned cargo drones and autonomous passenger vehicles to operate in dense urban zones. Howard, we see lots of startups in this space. What do you think about Skyroads and how are they special?
Again, I think it's very exciting. Skyroads is addressing an obvious need coming down the pike because right now air traffic control is manual, but given the number of aircraft that will be in the air, autonomous and otherwise, in the near future, it's got to be automated. There's got to be a system that's based on software and AI, and they have created such a system. They will not be the only competitor in this space, but they already have some pilot contracts with customers in adjacent spaces, and they're making good progress. So I think it's an exciting and interesting concept.
All right, well, here is Howard speaking to the founder of Skyroads.
So today I'm with Skyroads, and the co-founder and CEO of Skyroads, Corvin Huber, along with our old friend Kimchi, who has been at our events before and will serve as my co-interviewer today, especially because he is much smarter than me on aviation-related subjects. So thank you both for joining me today. I'm going to start by asking Gur to give a few words of self-introduction so that people know where he's coming from.
Sure. Thank you, Howard. It's great to be here again. I used to run the Amazon Prime Air program for about 8 years. I left 2 years ago, and I guess the context why this specific company is super interesting for me is one of the three things we had to do at Prime Air was airspace integration, right? Aircraft, autonomy on the aircraft, but then autonomy at the airspace level. And it's clear to everybody that the current ATC, ATO, ATM architecture isn't going to scale for the kind of missions we'd like to do in the future, regardless if they are drones for cargo, drones for life-saving applications, or air quote flying taxi applications. So every time a company is coming along trying to sort of solve that ATC, ATM problem, I'd love to hear about them. And here we go.
Terrific. Okay, so we're going to jump right into this with you, Corvin, and ask if you could give a few words of self-introduction and then tell us the origin story of your company and a little bit about what it is that you do.
Right, well, thank you very much, Howard. I'm pleased to be here. Again, my name is Corvin Huber. I live in Munich, Germany, which is where our company is based. I managed a number of aviation manufacturing companies throughout my lifetime, and I was always disappointed at the fairly small demographic that general aviation served. And I thought about ways of changing that. When this entire topic of eVTOLs and multicopters came along, it became quite clear to me that there was a unique opportunity here. You can position multicopters and eVTOLs in the sky much more precisely than you can heavily inertia-based winged aircraft. And that again gives rise to a completely new opportunity of managing traffic in a way that it hasn't been managed before, and actually creating a bit of a paradigm shift where you could, in theory, go away from controlling aircraft by humans to commanding them, just telling the aircraft where you want it to go. And it became quite clear to me that a lot of money was being spent on the mobile assets, on vehicles themselves, and very little on the actually automation functions of how do you make that work in a cooperative system. And that's exactly what we founded this company to do with a great team of co-founders and industry experts. So I'm an aerospace engineer myself. I studied at the University of Munich, which is a very theory-heavy exercise. Was a good thought process, very tough. Again, I've been in aviation for most of my life. I had a pilot's license before I had a driver's license. My parents needed to take me to the airfield to learn to fly. So I'm a dyed-in-the-wool aviator, but I'm also a very dissatisfied aviator because I don't like the way general aviation went. And I think we can do something about it, and here we are.
Terrific. Well, so maybe you can peel back the onion a little bit more, one layer for us, Corvin, and tell us, how does your system work? Describe the technology a little bit more, and describe how it fits into the current state of affairs, which, as you described, is not going to work for the future?
Well, I'm sure that most of you are aware of two facts. Aviation today, with very few exceptions, and Gur might not concur, but I believe that aviation today basically exists without any heavy data communication. You can fly a Boeing 747 from Frankfurt to New York basically without data communication. It relies on the old fact of verbal communication between controllers and pilots. And that is about to change. We need substantial data communication for telemetry, for all kinds of monitoring capabilities in a system, which means that high frequency data communication as we know it needs to learn to transmit data reliably. And data communication that we know today is not made for that, which means if you want to successfully manage aircraft in the sky, you need to couch the data communication in a system of air-based and ground-based edge computing that makes up for the deficiencies of data communication. But more important than that, we believe that there needs to be an air situation image, a digital twin of airspace that collects all data that are required to make valid navigational decisions for air vehicles, derive safe and deconflicted routes from that air situation image, and then again, transmit them to the vehicle where the vehicle then can act accordingly. This basic system, ground system, data communication, and an airborne system is the fundamental architecture, and it is designed with the final goal of urban or advanced air mobility in mind, and that is to transport humans against compensation.
And I assume that this takes into account and projects that there will be a vastly larger number of air vehicles in the future than they are today, because there's going to be an increase in drones, for example. Is that right? And you'll be taking all of that into account.
Absolutely. So if you look at the large studies that have been run worldwide, there's a pretty big variance. But even if you're on the conservative end of industry analysis, one sees that in general, it is expected that the number of drone flights will exceed today's entire aviation activities before the year of 2030, which means that, yes, there will be a huge number of flights. There will be a very large number of operations. Cycles will be relatively short. So there will be a very large number of operations that need to be managed and need to be managed in an automated fashion. And this automation is what Skyroads is about.
So I'm going to try to get Gur to jump into this pretty quickly, because he's been thinking about this for many years. But one last question before I invite Gur into this. So this sounds like an extraordinarily complicated proposition. I mean, you're dealing with both ground-based, air-based, and cloud-based software and hardware. I can't figure out if you're an infrastructure company or you're going to be competing with other companies that will provide similar services. Is this a natural monopoly? Is this going to be a situation that allows for different companies? How does this all fit into the ecosystem of aviation as it develops here?
That's obviously a brilliant question that we had to grapple with. We are assuming that the statements of the large regulators in this world, the Federal Aviation Administration in the US and the European Aviation Safety Agency in Europe, that their statements hold true. They actually want a competitive situation. They are expecting this not to be a winner takes it all environment, but they're looking at a federated system where industry proposals such as ours would regulate individual contiguous airspaces and then be federated into something that assures interoperability between these systems and interoperability with a view towards the air navigation service provider for today's legacy aircraft operations. So we do see a competition, but we do not see a digital issue where a national national government would have to decide that our proposition is the only valid proposition in operation. So basically, we would be seeing a reasonably high number of companies like ours coexisting happily for the world and competing for the worldwide market.
Gur, I invite you to jump in.
Okay, absolutely. Thank you. By the way, that point between a centralized architecture and a federated architecture is something that's very dear to my heart. I've been fighting this battle for almost a decade at this point. And I think anyone who grew up on so information technology, the word centralized always scares us because there's also a single point of failure. And anyone who looked at air traffic management safety records know that single point of failures do hit the network and hit it pretty badly. An example, the Chicago Center fire a few years ago here in the US that basically took out a big chunk of the national airspace because there was no sort of federated architecture. Nobody could step in and take care of that, the flights that were traversing that area. So first of all, Corvin, thank you for taking the federated approach. I think that's from a strategic perspective of how we grow the industry. We want many operators to offer the best possible services. I don't care if they are aircraft, avionics, or cloud service providers like yours. I guess one interesting question is that it seems to, and thank you for the conversation with before, it seems like you're taking a hybrid approach where clearly you're building the cloud architecture, but you're also building components that sit on the aircraft itself. That must have been a very complicated decision, right? Qualifying and certifying avionics on the aircraft is a whole other level of work comparing to building a cloud architecture. So tell us a little bit about that. Why did you make the decision? What choices sort of that gives your customers, etc.?
So to be quite precise about the answer, we didn't make that decision from a tactical point of view, but from a very strategic point of view. It is, if you've been in aviation as long as I have, and I think you have, you will know that so-called industry consensus processes in aviation are average between 15 and 18 years, which means that if you put new technology into an aviation market and design it to be a modular architecture from day one, you need more than 15 years just to write the interface control documents between the different elements of a modular system. In advanced air mobility, we do not have 15 years. The investment community will become disillusioned with us if it takes 15 years to get anywhere. So what we're doing as a company is we're taking a fairly old realization, and that is if you integrate a system initially, you can be faster in development. What does integration mean? In my parlance, it's the opposite of modularity. You prove the feasibility of an entire command chain or functional chain, and then once you have proven the feasibility and the viability of the approach, you then start parting it out and modularizing it, creating the interfaces and parting it out. So this is a long way of answering why did we make that decision. We believe that in order to efficiently and speedily prove that advanced air mobility can be automated, it makes sense to look at hardware and software simultaneously, and then find partners that we can part the hardware parts out to. So as a company, we are not looking to be an avionics manufacturer in the long term. We aim at being a system provider for automation for scaling urban air mobility.
Thank you.
Does that go to your question?
Definitely. I guess maybe a follow-up question would be, walk us through an integration scenario. Let's say you want to integrate with one of the UAM players. You pick the one that's your favorite, regardless of who they are. What do they do to integrate with you? They have an autopilot, they already have some communication, they already have a mission manager, sort of a mission computer on board. So how do they work with you? How do they integrate? How do they pay you?
Well, that's quite a number of questions, obviously, but I can tell you kind of in actual fact, we're working on several integration levels here and complexity levels. A very simple complexity level is the fact that we're actually right now adapting our system to manage several heavy camera drones simultaneously in order to replace TV helicopters at Larry Ellison's SailGP, right? So SailGP came back and said, listen, we want to be carbon neutral at some point in time. We want to get rid of our helicopters. And we tried to fly heavy drones with 100-pound, 120-pound camera systems on board, and nobody is allowing us to fly more than one at the same time, and certainly not in the vicinity of helicopters on any kind of RPAS system. So we want you guys to build a system that coordinates several heavy camera drones in the sky at the same time, providing full real-time autonomy to the director, saying where he wants his hook in the sky to be, where he wants his view points to be.
And by the way, just when you say heavy, but when you say heavy, how heavy is that aircraft? What kind of an aircraft is this?
300, 400-pound vehicles.
Wow, that's pretty big.
That's big, exactly. So, yeah. and that's very attractive to us because we're our air risk is reasonably small, but our ground risk is equivalent to any kind of eVTOL operation. So that's very good training ground for us, right? So the next level of integration is we're talking to drone manufacturers that are building quote unquote automated, so not uncrewed aircraft from day one, and they're looking for a solution for these uncrewed aircraft from day one. They're looking for solutions to create A to B traffic, very simple A to B traffic, which needs to be observant of the traffic conditions in its surroundings. There needs to be sensing to make sure that the airspace is clear, and there needs to be guidance of the vehicles. So yes, a vehicle such as this usually has some kind of RPAS remote pilotage equipment on board, but the remote pilotage itself is not a full integration, because conformance monitoring, is the vehicle really doing what I told it to do, is not part of a standard radio control RPAS system. So yes, if you ask kind of what is the level of integration? We have a small unit on board, a piece of avionics, aviation electronics, that actually continually provides a 4-dimensional guidance command to the vehicle, telling the flight control computer where it needs to go. We need to bear in mind that practically every vehicle out there, every manufacturer is currently designing its own vehicle safety architecture, internal architecture. In the absence of guidance through certification guidelines, people are being quite creative on what their vehicle architecture is. And we have decided that we want to bring the command for the vehicle into the vehicle via a specific box unit on board the aircraft, and then supply the aircraft with guidance. And our avionics are capable of talking to the aircraft specific system at very many different levels through a very powerful data integrator. So basically, we try to stay out of the vehicle design. However, the vehicle will have to integrate via standard interfaces, and the vehicle will also need to provide certain answers to our system: vehicle health status, performance data, etc., etc. So
that's actually, sorry, let me just follow up on that, Howard, thank you. That actually opens a really important question. Like aeroplanes generally, when everything is happy, nominal in aeroplane speak, nobody cares, we just enjoy them. The regulator and the public usually care when things go wrong, off nominal or emergencies. So walk us through an emergency scenario, right? Let's say you have multiple aircraft in one of these scenarios. One of them becomes less performant. I don't know, they lost the motor and now they have a reduced flight envelope, if you will. How do they coordinate? What does the system do? How do you maintain the safety of the airspace and people underneath, of course?
Well, you are aware of the fact that the full answer to your question is a 2-week seminar, but Obviously, in the total safety architecture, there are different contingencies require answers by different elements in the system. I frequently get asked, can we sense a flock of birds and can we safeguard a vehicle against a flock of birds? The answer is no, we cannot, because safeguarding against the birds is part of the vehicle certification and not of the navigation certification. So we have a similar situation here. We'd have to kind of look very closely at what the failure scenarios are. But in order to answer your question, let's look at a typical failure. So I would classify. I would look at two different categories. It's a failure in the navigation system, for instance, data outage. That could be a typical failure, or another failure could be a vehicle-based failure. For instance, energy is running low quicker than the vehicle originally thought. So those are two different types of scenarios that we might want to look at in order to answer your question. So
let's pick the latter one. Let's say, there's a power issue and the aircraft says, you know what, I thought I have another 10 minutes of flight. I only have 30 seconds. Please tell me how to land right now. And, that now, of course, you have to deconflict with everybody else.
Absolutely. So what this is one of the fundamental tenets of our design, that once the information is available to the system, there will be a real-time calculation of a fully deconflicted navigation solution. So once the vehicle has provided the navigation algorithm with the information that there is a problem, a new solution will be provided and also communicated to every other vehicle that makes sure that every other vehicle will be cognizant and navigate with the knowledge of a disabled aircraft. So let's look at this disabled aircraft for a moment. In keeping with very recent thinking, we assume that vehicles, as they transition along a route, will have to have emergency landing places available. So the vehicle will have to be, the vehicle certification will have to conclusively state and prove that they can make certain emergency landing points from any point in a route according to the specifics of that area. So let's say you fly a 10-mile route. The vehicle is able at any point in time to prove that it can travel for 2.5 or 3 miles in order to reach an emergency landing point. You could then segment your 10-mile route into 3 segments of 3 miles each, and the vehicle will be able to achieve safe landing anywhere in that route. That is what the vehicle has to prove to the system. Now, the system itself will have to provide a safe trajectory to that landing spot. So again, it's the responsibility for the solution lies with different parts of the element, but the central part of our guidance system is that at any given point in time, with the full knowledge of the system of the vehicle capability, there is a safe navigation solution. So the vehicle will never be left alone.
Safe and deterministic, I assume. Howard, you please go ahead.
Well, Corvin, the wonderful thing about your company and your technology is that you're not just a widget company. You're the opposite of widget company. So we actually need probably 2 or 3 hours just to do a fundamental interview of you, but we're running short of time. So I'd like to make sure we cover a few other key sets of subjects with you on this interview. First of all, if you could talk a little bit about what your revenue model is, and obviously you've shown yourself to be very sensitive to the financial, the timing needs of the financing community. So how are you going to bring yourself to revenue positive relatively soon? And second of all, how much traction have you achieved and will you achieve? You've already spoken about a particular customer already, but then third of all, I think we also need to cover your capital formation situation or history. So those are things we need to cover fairly soon.
Okay, let's keep it short. I mean, and Gur already asked the question, how do we make money? So fundamentally, aviation is used to the fact that a certain percentage of ticket revenue, basically the national economic value of transportation, a certain percentage of that goes to safety functions. In standard aviation, it's between 6 and 6.5%, depending on where you look in the world, but it's a reasonably large amount of money. So the United Airlines pays a bill to the FAA every month. Lufthansa pays a bill to the Deutsche Flugsicherung every month. So the safety aspect of traffic management is an accepted fact in aviation. And that's basically what we do. We are assuming that we will cooperate with local entities that enable advanced air mobility in a certain location. Usually the cities will be involved. It's some kind of public-private partnership that actually rolls this out. We're part of such a public-private partnership in the Los Angeles area. There's a beautiful little company that belongs to the city of Los Angeles called UML, Urban Movement Labs, who are actually trying to put together early embodiments of advanced air mobility in the Los Angeles metro area. We seek these entities out, we offer our service to them, and there's a stipulation that there will be kind of a financial return based on the operations that we enable. So that's the very fundamental view to this. We also see kind of added value streams in here, since we provide a communications platform. We can enable kind of over-the-top additional data services, passenger entertainment, communication, video feed. But even more importantly than that, we see kind of something that we internally call the NVIDIA model. You know, NVIDIA told Daimler-Benz a few months ago that, yes, we're selling you a $12 piece of silicone, but no, we're not going to ask $12. We're going to charge about $1,500 or even quadruple digit numbers for the silicone, because we're enabling your vehicle to do what it does. So we believe that the automation functions that we provide, the ability for the pilot to step out and to orchestrate vehicles simultaneously in a very efficient way has huge additional revenue potential.
And so tell us about where you are with commercial traction.
So we are currently equipping an entire flight test area in southern Germany with our system, and we have seen substantial interest from other cities to duplicate that. The city of Milano in northern Italy is looking at duplicating this. The city of Los Angeles is looking at duplicating this, which is a payable proposition, obviously, in the initial phases. We are looking at physical embodiments of our system for transport purposes, both in Turkey, in Israel, and in India, which will create a sustainable revenue. And this is kind of a pathway into the higher quality services for manned or passenger transport as we move into the next years of passenger transport. But we see a very smooth transition through simplified use cases into the more safety conscious use cases.
And what can you tell us about the history of your capital formation and your plans for the future?
We started off, we are a kind of a stock corporation or a share corporation in Germany, an Aktiengesellschaft. We presently have a fairly large investor base that was kind of that came through the seed phases. We have currently collected about 10 million euros, in these days very similar to $10 million, which our development has been based on. We're presently in a pre-A funding round, late seed or pre-A funding round. We're currently seeking about 13 to 14 million US dollars or euros. We have matching commitments from state funds in Germany that would match up to 7.5 million euros. and kind of we're moving into this pre-A round as we speak.
Terrific. So we're pretty much out of time, but Gerd, do you have any last questions? This is a fascinating presentation. Thank you so much. But Gerd, I'll let you have the last word if you like.
Yeah, this is such an important problem, and I think I've been hearing over the last 2 or 3 years that a lot of companies who are trying to deploy aircraft, you know, large UAM and small drones, and you see, I don't know, the latest I think database of configuration now is over 700 aircraft. But the reality is, maybe not all of them will succeed. Maybe 5 or 10 or 15 aircraft will actually remain when everything is said and done. But we do need airspace management, right? The old systems are just not going to carry the load. And I'm thrilled to see companies picking it up and running with it. That's very, very important, right? And the commitment to the federated model that FAA, ICAO, and CESAR has put in place over the last decade is great. That's going to give us a cheaper, open, and more economic airspace system. I think that's very important. So I would say thank you.
Terrific.
Well, thank you for those words are helpful to me, because we've been studying the space very, very closely and really trying to find out what actually makes urban air mobility work at the end of the day. And there is obviously a missing industry vertical here, and we're serving that, and we're very happy to do that.
Well, thank you both for joining us today.
Thank you.